Hello everyone, welcome to Baozi Training Leetcode solution. If you want the best marketing experience in North America, feel free to check us out at baozitraining.org. We're here to help you land your next dream offer. All right, so today we're going to talk about this interview question, Leetcode question, binary tree right side view. So essentially the problem is give you a binary tree. Well, it doesn't matter whether it's a binary search tree or not. It's just a binary tree. Return the right side view essentially is like the rightmost side of values. In this case, from top to bottom. So in this case, it's 1, 3, 4. Well, it is. I personally think this is actually a great problem, and I highly recommend any of us to solve it in both DFS fashion and the BFS fashion. So yeah, let's talk about it. I actually like this example a little bit better than this one because this is it's gonna be 1, 3, 4. This is like here, it doesn't under 3. There's no left or right children, so you have to somehow get this 5 in here. There are two trains of thought for this problem. One is using level order traversal, which is a typical BFS solution. We should at this moment all know how to implement a level order traversal from a tree, which is using a queue. It should be relatively simple. So once you are popping out element of the queue, you should only put the rightmost value into this array so that you return. So here is a quick snippet of the code. So essentially, this is a result. We are utilizing a queue, which is a linked list. So why this queue is not empty, and then you add the first root into this queue. Why the queue is not empty, you always record the size, and you essentially keep putting all the elements. You only recorded, in my case, is the last element from the queue. And then if the element is not now, the left or right children is not now, you just keep adding the element through the queue. Essentially, it's like, okay, you get the 1, you pop it out, you recorded 1, and then you start adding 2 and 3. So when you're popping out the 2 and 3, you always record the last element. In this case, it was 3. So the time complexity of this is O(n) because we visit each node once, and the space complexity is also O(n). Essentially, it will be, if it's a completed tree, it will be the last row, which is here, the number of elements in the last row, the bottom part of the tree. That's the space complexity. Another way we can solve this problem more smartly is actually using a DFS. Now we can actually take one step back. Is how do we actually implement a DFS, a level order traversal using DFS? So this is essentially the idea. We need a help of a map, and then for that map, the key and the value. I apologize for the outside noise. Sorry about that. The map, the key of the map is the depth of the tree, and then the value is an array of all the nodes. So let me quickly show you what it means by using DFS. So if you have, question becomes, if you given a binary tree, how do you do a level order traversal? So essentially output 1, 2, 3, 4, 5 using DFS. So the way to do that is more like using a map, which is the key is the depth of the tree, depth 1, 2, 3, and then the value is basically an array list of all the nodes or all the values. And then you are kind of like doing a pre-order traversal. By pre-order, what I mean is as long as you see a node, you put the node for the value, for the depth. So if it is there, so you just put the node there. So and then you go to the left and then you go to the right. This is basically a typical pre-order traversal. So once you go to the left, you say, the reason you always want to go to the left, because for a normal level order traversal, you want to be like from the left to right, right? So 2, 3, and then 4, 5, and maybe there's let's say a 7 here. You always go to the left, you put it to the map. So now level the map, the depth is 2. And then you actually have a node 2, and then you just always doing that. So now you have a 3, and then the value is actually 4 in this array. And then now you finish this, right? And then you go to the 5, and then because at the same time your depth is also 3, so 5 is actually added here. So that is essentially the idea of using DFS for a level order traversal. So you keep a map integer of all the list, and then you start with one of the depths, and then you're doing this recursion DFS helper, which essentially if it doesn't contain the depth, you create a new array, and then pre-order traversal, you first add the value, and then you always go to the left and then go to the right, and then later you will essentially loop through the dictionary and then output all the things. And then for this problem, the way we solve using DFS is exactly the same like this, same idea, except the map, instead of keeping an array list, we don't need to. We always need to keep a value, and then we can always override that value, because when you're doing this kind of order, right, because the right part always come to the latest. So for example, in this case, 4, essentially at level 3, it was 4, but once you are going transverse in your right part, the value is 5, you actually override this 4 to be 5. So with that case, you actually kept a right side view. If there's no 7 on level 3, this value will be 5, but if there's a 7, so after you traverse with 3, so all these things, then you go to right, and then it will override this to be 7. So if we check the code, it looks identical to, almost identical to the level order traversal using DFS, except this is an integer. And then you're using this helper, right? You put the value, pre-order, you go into the left, and then you're going to the right. And then always keep overwriting this value. Okay, the time complexity of this is O n, and then the space complexity is O to the log order of log n, because the map, the size of the map should essentially be the tree height, which worst case could be O n. I want to point it out. So these are my solutions, right? So I want to point out Leetcode has their official solution, which I don't really like. So I pasted the solution here. And it's a little bit weird how Leetcode thinks this is the best solution, because in DFS you don't really need 2 stacks. And also in BFS, all you need is a queue, you don't need maps. So take a read. So maybe there's something I might missed. Leave any comments below if you think so. Until then, I'll see you guys next time. Bye.